Hello, pre-calculus. Welcome. In this video, I'm going to talk to you about the tangent function and graphing the tangent function. So we've got a few definitions for tangent at this point. In this video, we're going to use our definition from the unit circle. It says the tangent function is equal to the sine function divided by the cosine function. So that's what we're going to use for this video. And I want to show you some values in a table for tangent. So we're going to put in an angle x, and I'm going to tell you the tangent of that angle x. And I'm going to give you a few different values because that's going to help us when we're graphing and thinking about it. And you can get these. So I'm going to take my first x will be negative pi over 2. If I plug that into the sine and cosine function, what I end up getting is that the sine of negative pi over 2 is negative 1. And the cosine of negative pi over 2 is equal to 0. So here I am trying to divide by 0, which we know, of course, makes something undefined. So tangent does not exist at negative pi over 2. This will come up later. And if I put in negative pi over 3 and do some simplifying, I get negative square root 3. And if I plug in negative pi over 4 and do some simplifying, I'll get negative 1. And if I plug in 0 and do some simplifying, I will get 0. Let's go ahead and do a couple positive values. So x and tangent of x. I also want to do for us positive pi over 6. Did I do negative pi over 6? I didn't. Oh, gosh. Before we do our 0, I'm sorry, guys. I want to do a negative pi over 6. And then we'll get negative root 3 over 3. And then we'll do 0 and get 0. Sorry, guys. It's just important to put in that pi over 6. And you'll notice there's a pattern here. Now when I put in positive pi over 6, I get positive root 3 over 3. And when I put in positive pi over 4, I will get out positive 1. And when I put in the square root of 3, when I put in positive pi over 3, I'll get out a square root of 3. I was getting ahead of myself there. And I hope that maybe you're seeing the pattern now. When I put in pi over 2, it's undefined. Here's the pattern I'm talking about. There's a few patterns going on here. But notice, if I put in negative pi over 2 or positive pi over 2, I get the same result. Doesn't matter. If I put in negative pi over 3 or positive pi over 3, I get the same result. I put opposite signs. So a negative input gives me a negative output. A positive input gives me a positive output. But the value, the distance from 0 is the same, but the sign is changing. And those of you who remember a little bit about our functions and transformation functions, you know that this pattern means that the tangent of x is an odd function. And just like sine and cosine, tangent of x is periodic. That means it has repeating values. And we've actually gone through one whole period. Tangent has a period of pi. So after this, if I continued going from after pi over 2, I went further, I would have a repetition of all the values that we've done so far. Just like how we have with sine and cosine. This means the reason we chose negative pi over 2 and pi over 2 is you can get a complete picture of what this graph looks like. If you just look at one period of the graph from negative pi over 2 to pi over 2, because the distance between those 2 points is 1. We do have some strange things with this graph, though, because remember, at pi over 2, at this pi over 2 point, that the tangent is undefined. Additionally, we know tangent is periodic, so at x is equal to negative pi over 2, or x is equal to pi over 2, tangent is undefined. But we also know that just like sine and cosine, tangent is periodic. And so what that means is that we also, in addition to repeating values, we have these repeated asymptotes. We have these repeated places where tangent is not defined. So every pi units away from these two asymptotes, you're going to find another asymptote. I'm going to show you a little bit more about that on Desmos. But what that means is we also have an asymptote. So if we have an asymptote for our function at x is equal to pi over 2, we also have one at x is equal to pi over 2 plus pi. We also have one at x is equal to pi over 2 plus 2 pi. We also have one at x is equal to pi over 3 plus 3, or pi over 2 plus 3 pi. And there's a pattern here. This continues. X is equal to pi over 2. And in math shorthand, we would say plus k pi. And k here is just standing in for an integer, like 1, 2, 3, 7, 400, whatever. If we add any multiple of pi here, we will actually get an asymptote. I'm telling you all this because it affects the domain and range. So the domain of tangent, we write it out this funny way. We say all x so that x cannot be one of these values where it's undefined, right? X could not be equal to pi over 2 plus pi k. X cannot be equal to pi over 2 plus pi k. And so and then we usually would tack on there, we would say where k is an integer. That means k is a positive or negative number, but not a fraction. In those examples that we gave before. So that's the domain. The range of our tangent graph is all real numbers. Negative infinity to positive infinity. And everywhere that our function is undefined, we have asymptotes. So tangent of x has asymptotes at x is equal to pi over 2 plus pi k. So let's talk a little bit about this tangent graph, and I want to show you this on Desmos so you can get a sense of it. So here is our tangent graph. This is what it looks like. It's kind of funny. It looks like a bunch of repeated cubic functions almost. So notice here we have these repeated undefined areas. We have these repeated asymptotes. I have one of them is a purple dotted line here that's a vertical. You guys see that? I'll turn it on and off. And I wrote this formula here. Pi over 2 times b plus pi over b times k. You can see my slider is set b is equal to 1. And as I move k, it'll change the location of that asymptote. It'll show you a different asymptote. So this might help you see a little bit better what we were talking about in terms of the domain. And see that everywhere there's an asymptote, the function's undefined. Right? We have a place where we're trying to divide by 0 there. Okay, but let's look at one period of this graph. In between these two dotted red lines, that's one full period of this graph. And then after that, everything just repeats over and over. So what I'd like to do now is to show you what happens as we change our values of a and b. I'm going to take off these here. So as I change my value of A, watch what happens to my graph. A is increasing, 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 all the way up to 10. So as I increase, it kind of straightens out a little bit. The asymptotes stay in the same place, notice. I still have my asymptote, my asymptote is in the same place. My asymptote stays there. But the shape changes a little bit. The shape changes a little bit. And then as I go back down towards 1, when A is in between 0 and 1, kind of fattens up. And check out what happens when A is negative. So something interesting happens here is my behavior around my asymptotes is different, right? I've reflected across my y-axis. So when A is negative, when A is positive. Negative, positive, negative, positive. We'll see that in the graph later, positive. But I do want to show you guys what happens when we change B. So just like when we affected the cosine and sine graphs, changing our B value is going to change the period here. Watch what happens. Oh, my period is getting much shorter. Or I can make my period much longer. And then we also have something that's important to note. Look what happens when B is negative. I have another reflection. So B is affecting the period of the graph. It's also affecting where I'm reflecting. A lot's going on with that B value. I hope that this is helpful for you. So I wanted to show you guys that little bit about the tangent graph before I show you how to graph by hand. So in the next video, I'm going to show you guys how to graph. That's a little bit of basic info about tangent. In the next video, I'm going to show you how to graph a specific 2 examples using some formulas from your textbook.